All right, we'll be starting right now. Good afternoon to all the attendees joining from Asia region, and good morning to all the attendees joining from Europe. Thank you all for being with us here today, and welcome to NiTiCo 45 Line Live Webinar. This will be the flow for today's session. Firstly, we will introduce the tool by sharing on the features and benefit, followed by the tool test report, where we will share several tool test simulation results which we have conducted against the leading brands in this segment. We will then delve into the product overview and end the webinar with a Q&A session. We will keep the webinar short and wrap the session under 45 minutes. I am Mark from the Account Management Department, and I'll be your moderator for today. Two of my colleagues will be joining me in today's session. First up, Nisha from Product Management, who will share the features and benefit of the NiTiCo 45 series, and also will cover the product overview of this NiTiCo 45 family. And we also have Jet from R&D Department, who will be sharing in depth on the various tool test results which we have conducted. We are going to disband the chat box features for now. So if you have any question at any time in between the session, please share them in the question box, which can be found at the bottom of your screen, and we will answer them at the end of the session during the Q&A session. Before we start, just as we have done previously, we would like to keep this webinar interactive. Hence, we will be pulling out some poll questions, which we will appreciate your participation to understand your market overview. As that being said, I'm going to launch our first poll for today. So for the first poll, which variant is the most common type in your market for the super alloy machining segment? So there is standard, standard with recess, standard with welded, and standard with recess and welded. For this, you can only select one option. So just select which one is the most common in your market. Right, I'm seeing that standard is leading the poll. I will still leave the poll for another few more seconds before I end it. Right, I'm going to end the poll. Here's the result. Thank you everyone for your input. We see that one of each variant has been selected with standard leading the poll. That's great news because we have all the variants available as standard. As you can see, we have four main tool types: the square end mills, the torus end mill, the multi-flute, and we also have the roughing end mill, which we not cover in this session. We will only be covering the three main series, which is the square, torus, and multi-flute. For all the tool types, we have them in standard, recess, welded, and also recess plus welded, except on the multi-flute, which is only available in standard and with recess. This NiTiCo 45 is ideal for machining resilient superalloys, which fall under the S material group, particularly nickel-based alloys such as Inconel, Hayes alloy, Warps alloy, and Monel, as well as challenging and durable stainless steel and titanium material. Optimal results are achieved within a hardness range of 36 HRC to 52 HRC. Therefore, for any superalloy or other materials like PMK, falling in this hardness spectrum, HPMT suggests utilizing this NiTiCo 45 program for superior performance. This material, which I have mentioned a while ago, can be found in various industries, but we have narrowed down to the industries we believe uses the most. The most common is in the aerospace industries, for production of aircraft turbojet engines, in particularly the discs, blades, and engine casing. For defense, in production of gas turbines, which can be found in naval vessels or patrol boats. in particularly the production of the propeller blades and submarine fittings. In energy, for production of gas turbine components such as scrubbers and also the heat exchangers. It also can be found in medical industries, in production of joint implants fixation screw, bone plates, knee and hip implants component. Now that I've shared on the targeted sector, I'm going to launch another poll. So this is the second poll for today. What are the common superalloy material to be machined by your customers? So if you do have customers in any of the above industry, do share what are the common superalloy material used by them. For this poll, you can select more than one option. Basically, everything is being very even. All four is being selected. Stainless steel is leading right now. I'll leave the poll for another few more seconds before I end and I'll share the result. All right, I'm going to end the poll. Here are the results. Thank you everyone for your input. Basically, all four materials are being selected with stainless steel leading the poll. I'm happy to inform our internal testing is done based on Inconel 718 material. So do stay tuned as we will come to that part later on. Next up, I'll pass to my colleague Nisha, where she will share what makes this NiTiCo 45 different by diving deep into the features of the tool. Over to you, Nisha.
Thanks, Mark. Hi, everyone. I'm Nisha from Product Management. We'd like to explain on the main features and benefits on our hero product for today, NiTiCo 45. Features and benefits are very important criteria or component to further enhance the tool's performance and efficiency in machining operation. As you can notice, the figure on the left has equal pitch and the figure on the right has differential pitch. The first feature in this NiTiCo 45 will be the differential pitch known as DP. Differential pitch simply means that the pitch is varied between the blades. This feature improves the performance and reduces chattering during machining by breaking the resonance. Overall, differential pitch leads to extended surface finish and longer tool life, which results in smoother cutting process. Next, we will move to the next feature, which is the differential helix, DH. Jet, do you know what is the benefit of having DH?
Well, from my understanding, right, differential helix or DH actually means there are different helix angles in one single tool. It also means that the helix angle for second flute will be different from the first one.
Thanks, Jet. You are correct. Differential helix basically means that the helix angle varies along the length of the flutes. This feature helps in chip evacuation to prevent chip congestion, which leads to higher efficiency in cutting process. Differential helix also helps in reduced chattering by breaking the resonance, which promotes a stable cutting operation. Lastly, higher tool can be achieved by distributing the wear evenly across the cutting edges. Next, we have the idle cutting edge, or internally, we also call this feature as a fake margin, because we adopted the eccentric grinding process to leave a small land width of about 100 microns at the cutting edge. This idle cutting edge land width is larger than perfect cutting edge. Idle cutting edge reduces cutting force during machining, which leads to stable cutting operations. The smooth and precise idle cutting edge helps in achieving high-quality surface finish product. It also helps in prolonging tool life and enhancing durability. NiTiCo 45 also comes with newly improved coating formula known as D0909. This newly improved coating formula comes with a higher thermal and wear resistance. This coating also promotes smoother chip evacuation. Lastly, the NiTiCo 45 is made up of UF plus material. To those who are wondering, UF plus actually means the ultra-fine grain cemented carbide. This carbide material comes with higher tool material strength and wear resistance. Most importantly, it comes with higher durability for material removal rate, which is a dream for all machinists. That's all on the NiTiCo 45 features and benefits. Next, I will introduce on the NiTiCo 45 newly launched item types. Basically, NiTiCo 45 will be introduced in 3 types. The first type will be the square end mills, which consists of 4 ADPs, which are the K92, K93, K94, and K95. All the mentioned products are equipped with differential pitch, differential helix, and idle cutting edge. The next tool type will be the torus end mills, consisting of 4 ADPs as well, which are the K96, K97, K98, and K99. These products are also equipped with differential pitch, differential helix, and idle cutting edge. These products are further enhanced with the S-gash design, which is the specialty to deliver tighter accuracy. The standardized corner radius for aerospace components help to reduce chipping and lengthen the tool life. Multi-flute will be the last tool type in NiTiCo 45, which consists of 3 EDPs, which are the K73, K76, and K77, which comes with 6 or 7 flutes. The multi-flute are equipped with differential helix only. This is further enhanced with the S-gash design and high helix angle. Better shearing in surface finishing with excellent chip evacuation are the benefits of having high helix angle. Well, that's all from me on the NiTiCo 45 tool type. Now, I would like to pass the floor to Mark.
Thank you, Nisha, for sharing in depth on the new NiTiCo 45 features and benefits. Next up would be the most interesting part for all you technical experts, the tool test segment. Here we will show how the tool performs on super alloy material. For this, I'll pass to the expert, Jet, to share on this. Jet, over to you.
All right, thanks, Mark. Now that we have already looked into the extraordinary features and also benefits of our NiTiCo 45 series cutting tools, I think it's time to witness their performance and also capability in action. So these 2 test results that I'm going to share are done on Inconel 718 material. These 2 tests will provide convincing evidence on the capabilities that we've been discussing just now. The objective here is to showcase how our tools, with their unique features and also benefits, perform in real-world scenarios. By the way, Mark, I believe we have another poll for the audience, right?
Yes, we do have a poll right now, and I'm going to launch them. So for the third poll for today is, which machining strategy is more widely used in the super alloy material segment in your customer base? For this poll, you can answer more than one as well. So the options available are side milling, face milling, slotting, ramping, and torpedo milling. Yes. For now, side milling is leading, followed closely with torpedo milling, and then with slotting. Right, we'll leave the poll for a few more seconds before I end it. All right, I'm going to end the poll right now. Here are the results. Thank you everyone once again for your participation. As predicted, side milling is the most common machining strategy when it comes to super alloy material. Okay, I'm not going to take any more of your time. I will pass on to Jet. Jet, take it away.
Right, thanks, Mark. You can rest a bit for now. Let me start sharing on our 2 test results. So here, you can see that our 2 test processes are actually categorized into 3 stages. So the first stage is more on the internal prototype testing at the initial stage only, while the second stage will be the final product comparing directly with all the other competitors for both 4 flutes and also multi-flute. Lastly, the stage 3 will be a very, very fierce comparison with very aggressive cutting parameters between HPMT and also the best performing competitor from stage 2. We will show you the results in the next slide. Before that, I would like everyone to pay attention to the details and also cutting parameters here, because it will be slightly different later in another stage. So basically, for the first test in stage 2, the material that we use here is Inconel 718, which is also widely considered as a very common material in the target sector that we mentioned previously. Please be noted that our comparison coverage is wide as we include both from Europe and also Asia competitors. We will not disclose who they are, but what we can tell you here is that the competitors A and also B are well known in Europe, and competitor C is well known in Asia. So due to multiple sites involvement here, the cutting speed, the feed rate, and other words, all the cutting parameters that we selected are based on standard conventional cutting parameters that is considered quite common among all the competitors. And as of the coolant pressure, it is controlled at 15 bar here. The machine that we use for the tool test is Huachon, which is a 5-axis CNC machine. In this slide, we are going to provide more insights on how we carry out the tool tests.
Jet, I'm not sure about the audience, but I'm a bit confused here. What do all the different A and B segment means?
I get what you mean, Mark. So, okay, everyone. So basically, one piece of Inconel 718 is used for 2 tools. The total Inconel 718 material used in one test is 2 pieces, as we have 4 tools to be tested in total. So what we do here is that the first tool will cut from area A1 to A5, and the second tool will cut from B1 to B5, and same goes to the third and also the fourth tool. I hope our simulation video here can help you understand and visualize it better.
Got it. Thanks for the explanation, Jet.
Okay, great. So in order to compare the test result, right, we will always start with capturing the images of all the tools before we do machining. Now, let's have a look on the condition of the tools after machining on Inconel 718.
Just wondering, are we just comparing the top area?
Not exactly. If everyone noticed on the red box, this is actually the area that we are all looking at right now. So technically, we will start with the top area first, as circled out in the diagram, and then only proceed with other areas as well. So don't worry, everyone. We will go through them one by one later. So as you can see, the difference in terms of performance are actually very, very significant. Competitor B is already broken at the 5th program, which is about 13883 millimeters squared covered. Competitor A and C already have a very heavy wear, while HPMT's K96 is still looking very great. Here, this is also the top area, just that it is another side of it, which we call it as gashland. Based on the images that we obtain, the result of condition of gashland are the same as well. Next, let's take a look at the middle area as circled out in the diagram. From all the inspection images, the difference between HPMT and other competitors are still very significant. The wear condition of HPMT's tool in the middle area is still the best, whereas others are either broken or having very heavy wear. These are the images that we observe on the bottom area. Before I continue, do you guys know why we separate them into 3 areas?
Perhaps because we tested it for 3 times?
Not really, Nisha. It is actually because that we are aware that some might have doubt on the consistency of the entire tool area. So during the tool test, we observe all 3 areas, including top, middle, and also bottom. So here I would say that we are very confident that after comparing them, HPMT's K96 is still the best one. As you can see, the wear difference is pretty obvious and also significant. Other than the torus end mill, we will also show the test results of multi-fluid end mill. So this is basically similar to the first test, but just with different tool type. All the cutting parameters and machine settings are to remain the same. Same machining program here. The first tool will cut from area A1 to A5, while the second tool will cut from B1 to B5, and same goes to third and also the fourth tool. Here are the images that show the condition of the tools before machining. In the next slide, I will review to all of you whether the performance is as promising as the 4 fluids we shared just now. All right, time to review its actual performance. So as usual, we will start with the top area first. As you can see in the top area, the difference in terms of performance are still significant. Competitor B is already broken in 3rd program, which is covering about 7986 millimeters square. And competitor C, tool is already broken in the 1st program, which is only about 2519 millimeters square. So I would say that competitor A is having a heavy wear, while HPMT's K77 is looking great with just some slight wear on the cutting edges. Same like what I mentioned before, this is also top area, just that it is another side of it which we call it as gashland. Based on the images that we obtain, the result of condition of gashland are the same as well. In terms of middle area, we can see that the result is same as the top area because both competitors B and C are already broken. Competitor A has a heavy wear, but HPMT has just acceptable wear condition and is able to continue machining. Same goes to the bottom area. It is still very obvious that HPMT's K77 multi-fluid end mill is the best after comparing among competitors.
Thank you for sharing on a two-test report, but the result seems too good to be true. Is it because you're using a conservative cutting parameter or cutting parameter that suits HPMT tools?
Yeah, Mark, I can tell that you are definitely paying attention. So this is also why I request everyone's attention early on. Okay, everyone, so from what I shared just now, right, we were actually only comparing with the same conventional cutting parameters that we concluded after comparing with all the competitors' conventional cutting parameters. But worry not, as in the next slide, I will share more on the next stage of our two tests. Before that, Mark, do you see any difference in stage 3?
If I remember correctly, the previous test, the cutting speed was 1000 RPM and 30 meter per minute. But here is 1590 RPM and 50 meter per minute. That's a whooping 50% increase.
Yes, you are correct. So not only comparing with conventional cutting parameters, we do include aggressive cutting parameters to test as well. The reason why we are doing this is we do understand that some of us might have concern or doubt on the capability and also performance of our tools under more aggressive cutting parameters. So in this stage, which is stage 3, we carry out the two tests with a very, very aggressive cutting parameters, and we will show you how they will perform under this condition. As what you notice, the cutting speed here increased from 1000 to 1590, and the feed rate increased from 170 to 450. But not only that, the cutting depth, or what we call AP, increased from 10 mm to 20 mm, which is exactly 2 times than before. So in other words, we are also utilizing almost the entire cutting length for this tool and for these aggressive cutting parameters. For the machining concept and process, they all remain unchanged as previous tests as well. The only difference here is just that we change it to the aggressive cutting parameters. As you can see, here are all the images to show you the condition of the tools before machining. I'm sure some of you might not remember the wear image or result from the conventional cutting parameters to test, but it's okay. We put it this way to let all of you to have even clearer comparison between conventional and also aggressive cutting parameters to test. So on top is actually referring to the conventional to test results. And at the bottom one is referring to the aggressive cutting parameters to test. For the first part, we are going to show the images and the results taken before the tools are broken. As you can see from the top area, competitor A's tool has a very, very heavy wear, while HPMT's K96 is still appeared to be able to continue further. Competitor A's gashland area is heavily chipped, while HPMT's K96 is still in good condition, even after all this aggressive cutting process. In terms of middle area, HPMT's K96 is still having a better wear rate than competitor A. Same goes to the bottom area. The wear rate of competitor A's tool is having a significantly higher wear rate compared to HPMT's K96. And for the second part of this stage 3, the tools here are continued to be machined further and aggressively until either one is broken. So it's slightly different from the first one. Also, not forgetting to mention that we did observe the spindle load condition under these aggressive cutting parameters to test as well. The spindle load while using HPMT's K96 is 2%, which is lower than competitor A's 3%. This also means that the machining process is smoother and causes less burden to the machine. Under this extreme and aggressive circumstance, we are very, very confident to say that HPMT appeared to be the clear winner, as competitor A's already broken first at about 10933 millimeters square covered, and HPMT's K96 is still in a very acceptable condition and able to continue machining even after running all 5 programs, which covered about 13883 millimeters square.
Okay, Jet, in
Same goes
terms of...
to- Same goes to the
sorry about that.
Gashland area, where HPMT's K96 has heavy wear, but competitor A's tool is already broken. For the middle area, competitor A is broken at 10933 millimeters square as well, while HPMT is showing acceptable wear rate. And as of bottom area, HPMT's K96 is still well intact. So to summarize all the 2 tests that I have shared just now, I can say that HPMT's 4 flutes end mill and multi-flute end mill are the best performer under standard conventional cutting parameters among all the competitors. As of aggressive cutting parameters, HPMT is still the clear winner here, as competitor A's tool is already broken faster even when HPMT's K96 is still able to continue machining.
Okay, Jet,
Yes, Mark, you were saying something?
Yeah, in terms of tool durability, HPMT tops. But what about the surface finish, as it is a critical component, especially when it comes to the aerospace industry?
I agree. This is a good one, Mark. I believe everyone here actually has something similar in mind as well, right? Let me show you something in the next slide. There is actually something worth noticing here. Can everyone see the white mark on competitor A's workpiece?
I'm going to answer in behalf of the audience. Yes, it's pretty obvious.
Yeah, I know, right? But do you know what it actually means?
I've no idea. Is it because of the chattering marks due to heavy vibrations?
Not bad, Mark. You are right. I believe some of you here are quite familiar with this, but for those that don't really familiar with it, please allow me to explain a little bit. So technically, this is actually caused by the wear of the cutting edge. So when the cutting edge of a tool has a wear, the vibration is much stronger and the surface finishing will be critically affected. This is why you can see a very more obvious white mark on competitor A's surface finish. As you can see, it is actually quite obvious that the surface finishing of HPMT is way better than competitor A. Other than this, try to see the chips formation, guys. The chips formed from our HPMT's K96 are quite even and short, while the chips formed from competitor A are irregular and also inconsistent. Also longer as well, I would say. Okay, last but not least from me, I have a video to let all of you visualize better on the actual machining process on Inconel 718 material. As you can see from the video, machining in Cornell 718 material actually requires a lot of coolant due to its tough and also high strength properties. It will generate more heat than usual during machining process. So the purpose of using the flood coolant here is to keep the temperature down. Alright, so I think that is all from my side. I hope my sharing can let all of you understand more on the NiTiCo 45 series tools. Now, I will pass back the floor to Mark for our next and also final poll. Let's go, Mark.
Thanks a lot, Jet. I definitely learned a lot myself from your sharing, and I hope everyone did as well. Next up, I will hand over to my colleague Nisha, where she will share more on the product overview of our NiTiCo family. But before that, as Jet mentioned, we have our last poll for today. So for the last poll, from your experience, who do you benchmark when it comes to these tough stainless steel and super alloy materials? For this poll as well, you can answer more than one. So if you have more than one benchmark or comparators, yeah, you can select them. I see there are some fill up as others. For others, we will connect with you on offline to understand who are your competitors. For now, we just focus on the main 4 competitors which we have given as an option: Goering, Franken, WNT, and Fraser. Okay, I'm going to end the poll right now. Here are the results. Thank you everyone once again for your input. Basically, all 4 competitors are selected, with Goering and Franken being the most common brand. Not surprised because their tools are pretty impressive, but give our new NiTiCo 45 a go. Compare it against the brand you're competing against. Let us know your comment. Okay, I'll pass over to my colleague Nisha to share on the product overview series.
Thanks, Mark. HPMT has 2 product lines which are well known as NiTiCo 30 and NiTiCo 45. In today's webinar, we'll be focusing on the NiTiCo 45. You can further engage with our sales team if you're curious on NiTiCo 30, which covers the lower range below 35 HRC. Our existing NiTiCo 45 has a cutting range from 36 to 52 HRC. Our new NiTiCo 45 is a suitable tool to be used on stainless steel and superalloy material. Also, the NiTiCo 45 can be classified as high performance tool. All right, as shown, the graph shows the NiTiCo 45 product against the competitor A, B, and C. Before that, I would like to brief the audience on the scale used in this graph. 10 being the highest, which is the best of durability, surface finishing, and cutting parameter criteria. While for the price criteria, the lower the scale, of course, the better it is, as it is cheaper. As we can see, NiTiCo 45 has a competitive price comparing with other competitors. Despite having a competitive price, NiTiCo 45 is not compromising with its performance. It has a high durability and fine surface finishing. Lastly, it works well too under the aggressive parameters as explained by my colleague earlier, Jen. Over to you, Mark.
Thank you, Nisha, for sharing on the product overview. For some of you who don't know, our NiTiCo 30 is one of our focus products and it is actively being purchased by many of our partners. It is available ex-stock, so if you haven't tested or adopted it yet, I suggest you give it a try together with the new NiTiCo 45. Just a recap, the NiTiCo 30 is for 35 HRC and below, and NiTiCo 45 is for between 36 to 52 HRC. Now we come to a Q&A session. I see we only have 1 question for now, but before we answer them, I'd like to share some of the ongoing marketing activities by us. First up, our new Optimum Short DPDH K86. We noticed there's a huge market for lathe machining, and due to demand from several of our partners, we have curated this specific tool to meet the market demand. The tools are available ex-stock. Thus, if you do have market for lathe machinings, give it a go and I can assure you, you won't be disappointed. Next up, we have our new Optimum DPDH promo box. Most of you may know our 918, which is actually our top selling tool due to its ability to machine various material and multiple application strategy. The previous 918 comes only in differential pitch, but now we have further improved the tool with the introduction of differential helix. So now the tool comes in both DP and DH. It is available in 3 variants: Standard, which is the 918DH, Recess, which is the 981DH, and Weldon, which is the 986DH. This promo box will be equipped with diameter 6, 8, 10, and 12. This will be a good introductory set, in particular for your new customers who may keen to be tested before actually adopting them. However, we only left with 200 boxes left. So if you are interested, do place your order soon to not miss out on this rare promo box promotion. Next up, we have our DRLX W05 long drill promotion. For those of you who have joined us in our last webinar, sometime back in November, where we share on the DRLX W05 tool, you would know how capable the tool is. If you never joined the webinar and don't know how capable the tool is, the only way to find out is to actually testing it yourself. For this promotion, every purchase of the DRLX W05, we will provide a complimentary pilot drill W16. So for an example, if you purchase 10 pieces of W05 diameter 5, you will get free 10 pieces of W16. This promotion is valid up to 20th May, so you have about 3 months to take advantage of this promotion. Lastly, we have recently launched our new website with improved interface and more user-friendly experience. Do drop by our website as we upload interesting and informational content to keep you up to date on the latest development in HPMT. Also, our NiTiCo 45 leaflet is finally available. Just scan on the QR code from the screen and you will have them on your mobile phone. The hard copy will be ready in 2 weeks, so do reach out to us if you'd like to have them. I will stay on this page a little while so you can actually whip up your phone and scan on the QR code. Okay, I'm going to move along to the Q&A session. So the first question we have is, are there customization options available for this NiTiCo 45 series, spec modification or for specific application? The answer is yes, customization is available. So if you have any requests on different diameters or different cutting length or total length, do send us an inquiry. We will code them and able to produce them accordingly to your requests. So to your question, yes, customization option is available. We have one question here. Do you have the cutting data for trochador milling on NiTiCo 45? Jet, you want to take this?
Yes, we did not insert the cutting parameters of trochador milling in the catalog, yes, but we do reach out to us as we will advise you accordingly.
All right, thank you. I hope that answered your question, Ian. Next up, I have this question. In what ways does the NiTiCo 45 series outperform other end mills in the market, especially in terms of cost effectiveness for super alloy application? Nisha, this seems like more of your area.
Yeah, I'll answer this. Of course, the NiTiCo 45 series outperform other end mills in the market, as NiTiCo 45 series offers a superior balance between the performance and cost effectiveness. While the initial investment may be higher than some conventional end mills, the extended tool life and enhanced machining capabilities make it a cost-effective choice over the long term, so reducing overall production costs. I hope it answers the question.
All right, thank you, Nisha. There's one question here. Are these end mills suitable for wide range of super alloy material, or are they optimized for specific alloy? Is there any effect on other material? Jet, your area?
Yeah, sure. Let me get this one. So actually, there is not much effect or difference in other materials that we already listed, which are steel, stainless steel, cast iron, and also superalloys. This is because in Cornell 718 is already considered the hardest material to be machined, which is also why we selected it for the two tests. I hope this answers your question.
Right, thank you, Jet. There's this one question Jet probably want to take. K96 and K77 helix angle looks around 40 degree. Is 40 degree is the best helix angle?
I would say that yes, this is through our two tests. So we have already attached the two test result as well. So yes, this is the correct one.
All right, thank you, Jet. We have one question. Are these tools available X stock? This one, I'll take it. As for now, we are only stocking up on the standard series and it will be available in the second week of March. For the other variants, such as the Recess, Weldon, Recess plus Weldon, it will be delivered in 2 weeks from the order date. However, we will keep stock on the other variants once we understand on the tool movement and the market better. So if you do have customers who are interested to test the tool, I would suggest to place the order first so we can secure the items accordingly and we release them as soon as it is available. Hope this answer your question. Okay, there's one last question here. Do you provide free sample tool for testing? No, we do not provide any free sample tool for testing. You're required to purchase them. However, we have a policy to issue a 100% credit note with a submission of a tool test report, limited to 2 pieces per tool. To simply put, the tools are provided free of charge, but indirectly, as it needs to be accompanied with a tool test report. Hope this answers your question. Okay, there's one question here. Do you still see any space for conventional roughing end mills in terms of DPDH end mill capabilities? Jet, can you take this or should I pass to Shankar?
I think Shankar
Probably
can.
I'll pass to Shankar. Yeah, Shankar is a more experienced one here. Shankar, can you take this?
Yes, Mark, which question?
Do you see any space for conventional roughing end mills in terms of DPDH end mill capabilities?
Okay, so the question is, do you still see any space for conventional roughing end mills in terms of DPDH end mills capabilities? For the conventional machining, we talk about that is not really the protective way of doing the conventional machining. DPDH, of course, you can use, but you cannot get the optimization if you're not using for aggressive cutting parameters. When you have the geometry, when you put the features, you better to use for aggressive cutting parameters. This is what our recommendations. In order to sustain this product for the long run and improve the production efficiency, we need to utilize the feature and benefit that providing to the market. Better utilize this with aggressive cutting parameters. Of course, can use it, but the benefit you won't see much.
All right, thank you, Shankar. I'm going to answer this question as well. Do you have a standard test report to complete? Yes, we do have a HPMT standard tool test report. I'll be happy to share them to you, Ian. However, you're open to use your own format as well, as long the important information is captured as cutting parameters, the result, comparator details. Hope this answers your question. Okay, that's all for the Q&A session due to the time limitation. For those questions which we have not answered here live, we will reach out to you via email to answer them. If you have any further questions or maybe concerns, you're most welcome to write to us and we will address them accordingly. Thank you everyone for sparing your time and joining us in today's NiTiCo 45 live webinar. I hope you find it beneficial, and if you have any questions, you're most welcome to reach out to us and our support team will be happy to assist you. I understand most of you would like to get a copy of this webinar slide. Don't worry, we will be sending out this webinar handout and it should be in your email by tomorrow this time. Do follow us on our Facebook and LinkedIn page to get the latest update from us, not to forget our website. And lastly, do follow us on our YouTube page, where we actively post interesting content on tool tests, videos, and some behind the scene on the daily operation here in HPMT. Also, to keep up with the latest trend, we are also available on TikTok. Yes, we are available on TikTok. So if any of you do have a TikTok account, do follow us as well. That's all from us today. Thank you once again and have a great day ahead. Bye-bye.
Thank you all. Have a great day. Bye.